Hey everyone. I haven't streamed for a little bit. So if anything's wrong or anything, if anything, just let me know. I'm gonna be streaming again. Trying to learn machine learning through Codecademy. Also, I'm trying to learn Python as well. I've been learning a little bit, but I'm not. I kind of have some of the basics, but I don't know it too well. And I'm trying to kind of learn this. It seems interesting. I want to see if I could use this for my own purposes, but there's kind of a lot to learn. So I'm gonna do that. Okay, where are we? So I've been actually doing this, and I've been watching videos. I'm not too far in. I think I'm in the bias weight. So this is the pro version of Codecademy. So I actually had to pay for this, but you can get a trial, and I think for beginners like me, it's really good. Free Codecamp has one. Okay. Also, I am a beginner in Python, not necessarily programming, but Python. Okay, so let me read this. Let me lower my music a little bit. If you guys have any tips for machine learning, let me know. I will welcome them. So let's read. So the bias weight. You have understood that the perceptron can be trained to produce correct outputs by tweaking the regular weights. However, there are times when minor adjustment is needed for the perceptron to be more accurate. Okay. This supporting role is played by the bias weight. Okay, let's write this down. Bias weight. Okay. It takes a default input value of 1 and some random value. So now the weighted sum should look like weighted sum. Okay. How does this change the code so far? You have to consider two small changes. Add a 1 to the set of inputs. Now there's 3 inputs instead of 2. Okay. Let's see what they mean here. Add a bias weight to the list of weights. Now there's 3 weights. Now there's 3 weights instead of 2. Okay. We automatically made these replacements in the code, so you should be good to go. Okay. The bias weight. Okay, let's see. Representing a line. So far so good. The perceptron works as expected, but everything seems to be taking place behind the scenes. What if we could visualize the perceptron training process to gain a better understanding of what's going on? The weights change throughout the training process, so if only we could meaningfully visualize those weights. Turns out we can. In fact, it gets better. The weights can actually be used to represent a line. This greatly simplifies our visualization. You might know that a line can be represented using a slope-intercept form. A perceptron's weight can be used to find the slope and intercept the line that the perceptron represents. Slope equals minus weight. Okay. The explanation for these is going to be on the scope of this lesson, so we'll just use them for visualization. Okay. Next. Whoa. What's going on here? I don't feel like looking at this thing. Oh, okay, stop. Finding a linear classifier. I'm just gonna write linear classifier. let's recap what you just learned. The perceptron has inputs, weights, and an output. The weights are parameters that define the perceptron, and they can be used to represent a line. In other words, a perceptron can be visualized as a line. What does it mean for the perceptron to correctly classify every point in the training set? Theoretically, it means that the perceptron predicted every label correctly. Visually, it means that the perceptron found a linear classifier or a decision boundary that separates the two distinct set of points in the training set. In the plot on the right, you should be able to see the linear classifier that was found by the perceptron in the last iteration of the training process. Okay, so this is new. What's next? Neural networks. Congratulations, you have now built your own perceptron from scratch. Let's step back and think of what you just accomplished. Okay, neural networks. Okay, so inputs, perceptron, output. Okay, let's step back and think about what you just accomplished and see if there's any limits to a single perceptron. Earlier, the single data point in the training set were linearly separable. A single line could easily separate the two dissimilar sets of points. What could happen if the data points were scattered in such a way that a line could no longer classify the points? A single perceptron with only two inputs would work for such a scenario because it cannot represent a non-linear decision boundary. That's when more perceptrons and features come to play. By increasing the number of features and perceptrons, we can give rise to multi-layer perceptron, also known multi-layer perceptrons, also known as neural networks, which can solve much more complicated problems. With a solid understanding of perceptron, you are now ready to work and dive into the world of neural networks. Okay, cool. Up next, our quiz. Sure. Quiz. Let's see if I understand some of this stuff. True or false, an activation function is a special function that transforms the weights into the desired constraint outputs. Yes. I'm gonna write that down because I didn't fully remember that. So an activation function is a special function that transforms the weighted sum into a desired constraint output. What is the default input for the bias weight? I guess 0. Oh. What does the activation do below? Self weight. If the weighted sum is positive, return. Okay, got it. Which of the following is correct weighted sum formula? Which of the following is not a component of perceptron? Okay, what was used to find the the weight rate. Oh, weight. Okay, suppose the actual label is 4, the predicted line is -2 for data point. What is the check? So actual label Up next, start next project. Okay. What's the project? Perceptron logic gate. Oh, Lord. Let's see. Do I need to do this? Perceptron logic gates. I don't think I have to do this. I think I can get started with TensorFlow. Getting started with TensorFlow. Okay, so implementing neural networks, goal of this unit. The goal of this unit is to take that. In this section, you'll find you will find code, your own ways to fine tune your program with hyperparameters. After that, you will get to work on your own regressional projects where you have to design and develop your own neural network to solve a given problem. After this unit, you'll be able to translate abstract deep learning concepts into Python. Just trying to see if my stream is working. Okay, seems to be working. Okay, I could close that. Okay, so the goal of this unit is to translate abstract deep learning content to the Python, design an neural network from scratch, use deep learning models to solve regression problems, tune the hyperparameters of your model, and improve its performance. Okay, cool. Start next lesson. Okay, so implementing neural networks. Okay, let me put my headphones on. A neural network, just like any machine learning model, learns how to perform tasks by processing data and adjusting its model to best predict the desired outcome. Most popular machine learning tasks are classification, given the data, and true labels or categories for each data point, train a model that predicts for each data example what its label should be. For example, given data of previous fire hazards, our model can learn how to predict whether the fire will occur for a given day in the future with all the factors taken into account. Okay, regression, given data and true condition continuous value for each data point, train a model that can predict values for each data example. For example, given the previous stock market data, we can build a regression model that forecasts what the stock market price will be at a specific point in time when the data is available. Parametric models such as neural networks are described by parameters, configuration variables representing the model's knowledge. We can tweak the parameters using the training data, and we can evaluate the performance of the model using hold out test data the model has not seen during training. Okay, take a look at the main components of a neural network learning pipeline depicted in the workspace. Input data. This is used to train a neural network model. You need to provide it with some data. And optimizer. This is an algorithm that's based on the training data. Adjusts the parameters of the network in order to perform the task on hand. A loss or cost function. This informs optimize whether it's doing a good job on the training data and how to adjust the parameters in the right decision. Evaluation metrics. These tell us how well the current model performs on validation data. For example, mean absolute error for regression. Okay. So forward pass. Error loss automatic. Okay. Predicting medical costs, loading the data. Every machine learning pipeline starts with data and a task. Let's take a look at the medical cost personal data. Okay, which consists of several columns with the following description: age, number. Okay, okay. We would like to predict the individual medical cost charges given the rest of the columns features. Since charges represents a continuous value, we're performing a regression task. Think about the potential implications of using sex or BMI to predict what the individual should they even be used for prediction. Yeah. Our data is in CSV format and we load it with pandas. Okay, so I guess panda is what reads this CSV. Okay. Next we split the data into features, independent variables, and the target variables, dependent variables. The panda shape properly tells us the shape of data, a vector of two values, the number of samples, and the number of features. To check the shape of our data set, we can do use the dot shape property of pandas dataset to print the number of samples of the label series. Okay, data set, features, labels. So they want me to use to print this to print the shape of pandas series, we write the following: my series dot shape. You need to labels. Print labels dot shape. You need to replace labels is a vector with dimensions. The first dimension is the number of samples. The second print labels dot describe. Go to this. So I'm gonna look. data preprocessing, one hot encoding, and the standardization. One hot encoding of categorical features. Since neural networks cannot work with string data directly, we need to convert our categories features region into numeric. Okay. One hot encoding creates a binary column for each category. For example, since region variable has 4 categories, the one hot encoding will result in 4 bytes. Features feeding data into train and test sets. In machine learning, we train a model on training data and we evaluate its performance on held out set of data, and our test sets not seen during the learning. There's a lot to take in. I might finish for today.